hints or this one?
Hints, you can go to the hints. Yes, zoom in a little bit so I can see. Okay, so now for the first case, we're talking about this. You need to add now this constraint.
Yep.
This one needs to be repeated. It's not going to be only one. It's going to be multiple of them. So let's take an example here. In case that lost, for that, you need to add constraints for each power generator. So each one two generators constraints. So let's start now with generator 2. So what you do is say 2 min is less than D2 plus D2 by B loss.
Yes.
Like this max. So this is a decimal variable. This is a constant. Okay. So you need to determine this for in this case. So the D factor, you know how to do it, right? You determine the D factor based on the loss of generator 1. So you know that, right? You know how to do it.
Yeah, we already calculated this one.
Yeah. So
this one
for, yes. Since you are talking about generator 1, this will be BG1 or B1.
Yeah.
So this is before the contingency. So but basically this is this part. This part here is constant. So then next, so you add this constraint, and then you add also another constraint for generator 3. Right? You say B3 min is less than B3 plus D3 B loss less than B3 max. Right?
Yes.
And then you also add one for 4, for 5, for 6.
I don't understand. So this one, you mean that we need to have a solver and then add this in the unequal constraint?
Yes, you add it at the A matrix for the inequality.
Oh yes, for inequality.
Yeah, or there's another way. Since this is constant, this part is constant, you can actually move it here and move it here in a minus sign. And then you can add LB and UB matrices. So either you add LB or LB and UB, or you add it in the.
Okay, so as we can see here, the P2 minimum is 0. So in that case, we need to change the P2 from the negative value.
Yeah, it's normal. It's okay.
So this one, you mean like if it's 0 and then the constraint change to minus B2 P loss?
Yeah, this is fine. This is fine, but this will not impact it. Do you know why?
Why?
Because you have another set of constraints. You still have B min 2 is less than B2 is less than B2 max. So you still have this one. So this one will ensure that B2 will never be below 0. So basically these constraints, you add them. So you keep all constraints for question 1, you keep them, and you add new ones. So you still have this one. So even if the other side is negative value, that does not mean that B2 will be negative. B2 is forced to be 0.
Yep. Okay, so I don't understand. I'm quite confused right here.
Yeah, so it's like what we need to understand here that you need to repeat all these constraints. You need to repeat for each contingency. So each contingency that you have 6 generators.
Yep.
And here you have to have 5. So you have 6 by 5 constraints like this.
Yes.
So you have 30.
So, and then use the solver every time the contingency happen?
No. You add all of them. You add all of them one time. So you have one, and then you have one problem. So you add. You have more constraints.
I don't understand. So you're saying that we have 30 constraints here?
Mm-hmm.
30 constraints. So as we can see here, the Pmax. So we are basically changing the Pmax, right?
Yeah.
We basically, so we have the 2 Pmax have different value, have 5 different value, and can the maximum one among these 5, and then apply to the equation, the unequal equation, and then get the results, right?
Yes, this is possible, but you have to understand that in your write-up, explain this. Try to focus on this because this is the correct way to do it. And then say that for ease of coding, to make it easier to code, you could use the maximum.
Yeah, well, I'm definitely going to use the maximum. I don't want to run time together.
Yeah. So you're saying that you find this value, you find the maximum of this value, right?
Yes.
And then you use it as a Vmax.
Yes.
Okay, this is correct in coding. When you code it, this is correct. This is fine. However, I'm saying like when you do the formulation in your report, explain this. You need to talk about this.
I need to talk this. Okay.
Yeah. And then at the end, you should try to say that, and when we code it, we use the maximum value of all these. Something like that.
Okay. Yeah, I'll do that.
So think about it this way: you don't have like your formulation. You can say a different formulation in your report, and then you do approximation. You do assumptions, whatever, in order to make your code easier. But try to explain as much as you can in formulation. So don't just put the final one. But explain your thought process. How did you arrive to this answer? Try to explain it.
Yes. What about the line outage one? So if we are saying that in the generator outage one, we change the maximum value of the power of the generator. What about in the line max? Do we change the P line flow max in line outage cases?
Yes, you can do the line in different ways. You can either include it in the optimization, right? Or you could do it this way. You find all the cases, this difference that changes in the line, and include it also as a limitation on the line.
So are we going to add a limitation on the line or on the generator?
You need to have both.
Have both of them?
Yes.
What about the generator?
You want to ensure that you have no overloading.
Okay, what about the generator one? Do we need to confirm the Pmax, the P line max as well?
When you are talking about generator one is lost already, right? But when you're talking about the contingency where generator 2 is lost, you need to include generator 1.
Of course.
When you lose generator 1, you don't have to worry about it. But when you lose generator 2, you have to worry about generator 1.
I didn't asking for the generator one. I'm asking the line flow. So in the generator outage cases, do we worry about the line flow and we change the line flow max as well or not?
Yes, it is.
We have to change the line max as well, right?
Yeah. Maybe it's not. This is maybe the most practical and most, let's say, easy to understand way. But if your code is working this way, it's fine. But you have to include both the generator limits and the line limits. All of them you have to include. And you have to also modify and make sure that there's no overloading.
Okay. So let me rephrase everything again. So in the question 3A, we need to first of all try the generator outages, and in this case is that put a new constraint, and then we solve every one of them and compare the new the constraint and choose the maximum Pmax and solver. Also, we need to check the flow as well and the line flow as well, and then check the delta line flow max and put in the constraint as well.
Yes.
In the line outage one, we check the 41 contingencies and we check the generator, the data generator. And then we check the line flow. And then we put both the limit on the line flow max and also the generator, the PG max.
Yes.
Okay, so, and then in the question B, and then in the 3B, we don't know again, what should we do here?
Yeah, so can I clean the comments so I can explain what you do?
Yeah.
Okay.
Clean all drawing, I guess, yes. First, we can't hear you. Ferris.
Yeah, you hear me now?
Oh yeah, I hear you now.
Okay, so what we see now, you have this delta B.
How can we get a delta PI in the first case?
Yeah, let me explain to you now. So the delta PI is actually, let's say, it's a control variable, or it is a decision variable. So you have to include it as a decision variable, actually. So let's try to think about it. Now, all your constraints that we have, the constraint that you have here, including the OBF, the line limits, the generation limits, all correspond to what? To the base case. For this base case, you have BI value, you have theta value, you have BIJ values, right?
Yes.
So now what you want to do is to add another set of equations that correspond to contingency number 1, let's say, which is generation. And for this one, what you need to get is a set of thetas and a set of BIJs, and also the difference from the base value. On this value is the same as this. But now you have a difference. This difference that is actually added. So for example, let's say B2 was equal to 10 in this first case. Okay? Yeah. And in the second case, this is equal actually to 50. So how much is your BI2 here? Or delta BI?
Why we are setting the P2 to 15? Why?
No, I'm not setting it. I'm saying that, for example.
But the PI is like, it's coming from the 15 and the 15 is come from nowhere.
No. Listen, I'm saying, what if, an example, what if B2 is equal to 10, and then a contingency happened that you lost generator 1, right? And then B2, generator 2, actually it changed to 15, right? To recover the lost generation in generator 1. Is this clear?
Okay. So can I just repeat that? So in this case, we just put in the PG1 equal to 0 back to the OPF, and then we can get PG2 value.
Yes.
You're saying like this, right? Okay, then make
yeah.
So we just
I'm saying you do this. I'm saying you do this in one step. In one step, actually. So all of this in one step. How? By adding different set of constraints. So let us just try to think about it. So in this case, let's say in this case, you have this delta BI is equal to 5, right?
Yeah.
Okay. And this is equal to 10. So 10 plus 5 is 15.
Yep.
Okay. So now what you need to have, you need to include full set of the power equation. So you have all the constraints here again. You will have the OBF, and you will have the line limits and generator limits here also. All of them based on these values.
Yes, of course. Yeah.
Okay, and then you have another contingency also. You have contingency number 2 for generator 2, gen 2, and then you have 3, 4, whatever you have. So you have many constraints available, and all of this is all of it will be your constraint matrix. Some of them will be an A matrix, some of them will be A EQ, depending on if it's equality or inequality.
You made me confused.
So actually, just need to explain to you so it can be easy for you. So this will be actually, so you have in your generation, or sorry, your formulation, you're going to have the base case value variables, and then you're going to have the variable for contingency 1, contingency 2, all the way until the final contingency, so 48 contingency. So you're going to have a lot and a lot and a lot of variables. Okay, got it? However, I understand that this doing the code this way might be too complicated and might be too, let's say, there's a lot of room for mistakes and issues. Okay, so as a way that you could actually work, you could use this way as a step-by-step. You could actually do it, and it should be working fine.
Okay, so we just do step-by-step, and then we, so. Oh my God, my cat. So you can then have a different value of the G2 here, and then we choose the maximum and put in the constraint and do the OPF again, right?
Yes, yes. So you need to have multiple OPF first to find these values, and then have one final OPF that use the maximum.
Yep. Okay, I get it.
But this is not really, let's say, the correct way on the way that you do it. Usually they do it in one shot. They do it like I explained. They put many decision variables that account for all possibilities, and then they deal with it.
We can still using the simple one, right?
Yeah, you can. But just explain it in your write-up also.
What about the line outage cases?
This is including the line outage.
Oh, this including line outage as well, right?
Yeah, because I said you have 48 contingency.
Oh, so yeah, so in this easy way that we doing the generator outage is setting the generator to 0. What about the line? Yeah. Do we set the upper limit and the lower bound to 0?
No, for that you need to change the B matrix.
The B matrix, putting the line, the Bij equal to 0, right?
Yeah.
Do we need to change anything else?
Yes, see, if the B matrix is here, and you have, let's say, you have, say 5, 2, 3, 2, 3, and then this will be 2, let's say 2 here and 3 here. So this is minus, right? So let's say this is the case, and you want to shut down this case, this line. So this will be 0, right? This one will be 0. Mm-hmm. This one will be 0.
Yeah.
Right? And then the summation of them, like all the, you need to remove it from the diagonal elements. So this one.
Here and here and here, right?
And here, yes. So this will be 0, and this will be 2.
So just changing the B matrix. And do we need to change anything other than the B matrix?
No, but yeah, and remove the constraint also. The constraint that talk about this line. So if you talk about line 1 and 2, 1 to 2, remove the constraint of this one. So there is no constraint related to this one. I mean, when we talk about the flow min less than flow max.
Yeah, I get it now.
Yeah. So that should be fine. Yeah.
So the question 4 is using the same method as using the question 3, right?
Yeah, exactly the same actually. But now in question 3, we are talking about B loss, right? B loss. And in question 4, it will be B loss is equal to the difference between the forecast and the actual scenario.
Yeah.
And here, for this one, delta BI will be based on what? Will be based on the scenario. So you need to check what is the BI if scenario number 2 happened, scenario number 3 happened, scenario number 4, all the way into scenario number 9, sorry, or scenario number 10. And then you include these values in the same way that you did in question 3.
Yeah.
So question 4 need to have all, right? Question 4 need to have all the things stuff from question 3, and you add more stuff. So it's a build up on question 3.
Yeah. Also, can I ask another question? So in question 3, that what we want to get for the solution, is that the solution PG or the action that we want to do?
PG. You would say that these PG are skewed. That means if any of these scenarios happen, it will be also within limits, so there is no overloading. What we want to talk about is actual bit dispatch, the PGs, plus the, let's say, maybe maximum limits, maximum delta. So you could also report the maximum delta for each case. And you could also like talk about the cost, focus on the cost. Since remember that one of the important factors in this workshop is to understand the having security and having too much security, and also having what is the cost impact.
Paris, I need to repeat the question again. So in the question 1 that we got the cost and we got what PG, and then in question 2 we'll find out there's no light overloading, which means 3 we will get the same answer that we get in the question 2.
No. You still have like the, let's say, the delta values there. So you're including, you are enhancing. Actually, let me think about it.
Yes, you will get exactly the same result as you got in question 2 and question 1, because there is no overloading. Even if you changing the limits of the P line and also the PG, there's nothing gonna happen. The price will be the same. Barris, I can't hear you.
Yeah, sorry. Can you hear me now?
Yeah.
Oh, yeah. Just to make it easier for you, try to choose an hour that is heavily loaded.
Okay.
So maybe you can at least get some over.
Yeah. So we need to choose 1 hour that's heavy loaded, and we're trying to find out this line overloaded.
Yes.
Okay.
Yeah, I think this is but then I think whatever result you get, if your process is correct, if you explain well in your write-up, in your explain and provide enough details, this should be good, like a good mark in this assignment.
But it will be hard to summarize.
For like a lot of groups, and it's not confusing. So try to explain and show that you did good work, even though that you might have mistakes, not perfect answer. Like more of this.
Because in the question 5, it also asks us to compare the price as well. So if we didn't get a different solid results, so we have to find a heavily loaded hour and then get a overload.
Yes. Maybe this makes it easier for you.
Also about the number of contingency. For the generator, there are 6 generator and 1 wind. And also for the line that we just got 41. 47, is that right? Because
47, but I also consider the generator for the wind as generator, so it's 48. 47.
Yeah, but we didn't.
We said the wind could be a negative load. We chose to use a negative load, so it's going to be 47.
Okay. Yes, because we think there's no change using. Changing the generator number 7, because it's really it's only like
so that's cheap. It should be always the.
But you hope us to do the test for number 7.
Yeah, then saying like if you choose to like model the wind as a negative load, that means you only have 47 contingency. Only 47.
We make it to
yeah, 48. You need to include it.
Okay.
Exactly the same. Maybe exactly the same way.
Yes. 1 contingencies.
Yeah.
Yes, I will screenshot this one and then we move back to the instruction. I think that's more clear.
Sure.
Why there are 7 people in the group chat?
There is also 2 guys.
So there are people from another group?
I think so. Yeah. Anyway, let's continue. It's okay.
Oh.
That's fine.
So this is question. So basically after we finish the A and B, and then we can do this one, changing the step, and then we can get price results. And the fourth one is simply the same with the 3.
Yeah.
And you ask us to calculate the cost as well.
Yes. For the wind, for sure, we're gonna have differences because it's actual changes.
And then in this case, just because in the question 5, it asks us to like saying what's the difference between the prices. So yeah, we definitely need
to try to find an overload condition. And for question 4, for the wind, for sure gonna be differences. Since the wind is different, you have different scenarios with that will cause different loading on the other units. So for sure you're gonna have differences in question 4.
So in question 3, that changing the constraint is the action, right?
Yeah. So as I told, like this is maybe not the best way to do the formulation. However, like it's a good approximation of the solution. The best way would be actually to include, like, to make one very big problem that includes everything.
Yeah. Okay, we will work on this one. And can we send more emails to you if there's anything else that we can't finish?
Sure. But try now to focus on to produce the report since there's not much time remaining. As I thought, like try to detail your process, your thoughts, the steps that you take, and why you think will happen. So as much as you add in the report will help in like getting a better mark, even though that might not have the perfect solution. Putting more information will help in getting better marks. And as I thought, we understand that this might be difficult for some groups, so we would like showing is really important here.
Yeah. Almost finished. So as you said, if just simply using the distribution factor and times the load of line, and then the result will be given. And if in that case we almost like finish everything.
Yeah. Digital, whatever way you use, just explain it well, and should be fine. As I told you. Yeah. The thing is about this type of workshop, there is many ways you can do it. Like you can do it in multiple ways. So if you explain well how you do it and the results make sense, then it should be fine.
Yeah, then it should be work well. Thank you.
Okay, no problem. Good luck with the remaining. I think there's one other group that is here, so I will check.
Yeah, bye.
Bye. Yeah.